Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at some of the properties of logarithms, in particular the inverse property and the product property. So let's go ahead and begin. So we're going to start with the inverse property. Now, the reason that you need to be familiar with these different properties of logarithms is that sometimes you have to manipulate them to achieve other goals in terms of like solving for a x or solving for a y or whatever, or simplifying or whatever. And so having said that, the inverse property, we're just going to write the theoretical example of it and then give a literal example of it. So in other words, we might have something like the following here. Imagine we have log of x with the base x with x to the y power. This is all going to equal y. Now what this is basically saying in fancy mathematical talk is this. It's asking kind of what this question here. X to what power is xy? So in other words, what do I have to raise x to in order to get x to the y power? Well, that's pretty obvious, because if I had to draw that out, I'm going to say, okay, x to my unknown here, x to the y. Now here's the beauty of this. Because these have the same base, I just remove these, and so my question mark equals equals y. Excuse me. My question mark equals y. Basically, that's what's happening here. This is a y, not an x. Let me make sure that's clear. That's a y. So that's what's happening. So in other words, when you have a base and then you have this same number here as the whole number, if you will, raised to whatever exponent, the answer is going to be that exponent. So to give you a literal example rather than this theoretical stuff, let's take a look at the following. Log of base 5 with 5 to the second power equals 2. So what I'm asking is this. I'm asking 5 to what power is, or you can say equal is 5 squared. In other words, if I did like this, 5x equals 5 squared, they have the same base, x equals 2. That's what's happening. So when you have the logarithmic base and then the whole number there, when they're the same and it's raised to an exponent power, you can they kind of eat each other, and you're only left with the exponent as the actual answer. Again, this can come in handy in particular situations. We're just talking about this at a broad view right now. So let's take a look at the product property. So the product property is a little bit messier, but this is kind of what it looks like. Again, this makes way more sense when you need it rather than when you just talk about it in a video isolated like this. So log base a times m n is the same as log base m plus log base n. All right, so that's what's happening. So when you have two whole numbers, two numbers in the parentheses multiplied to each other, it's the same as if you add them and you have the separate logs like that. Now, again, to understand this, the easy way to understand it is to just see an example rather than try to explain it on the theoretical level. So imagine I have log base 3, and I have the following numbers there, 9 times 27. In other words, this should equal the same thing, but I'm going to show you how it works out first. So another way to write this is that I add in the exponents. So watch what I do here closely. So I put log base 3, and then I put 3 squared dot 3 to the third, like that. Now for the A students, you can probably already see the answer, but we got to go through the whole process here for people who may not be as familiar with this. Now, why did I do 3 squared and 3 to the n? Because 3 squared equals 9, and 3 to the third power equals 27. That's why I did that. And so this is another way of seeing it. So now watch carefully here. When you have the same base, when you're dealing with exponents, you can just remove the one of the exponents and combine them. So it looks like the following. So now I still have my log base 3 here, but now I have 3 squared plus 3. That's what it should look like because we have the same base here. The rules for logarithms are very similar to the rules for exponents if you've been keeping track. Now, here's something else that you may have noticed. Also, that because we have the same base here and the same number here, we can remove these, and we're essentially left with the following: 2 plus 3. That's what we're left with. And so now this is what we can do. We know what we need to do next, because what's happening here is that we're going to use the inverse property, because that's kind of what it's built on, and we end up with the following. So we end up with log base 3 to 9 plus log base 3 27. Now, why does that work? Because log base 3 9 is going to give you 2, which takes care of this guy right here, and log base 3 27 is going to give you 3, which takes care of this guy right here. That's why they're equivalent expressions. So when I say log base 3 times the quantity of 9 times 27, it's the same thing as saying log base 3 9 plus log base 3 27, because when you simplify all this nonsense over here, you end up with this 2 plus 3, and when you simplify all this nonsense right here, you end up again with the same 2 plus 3. This is how we know that the product property works, and that's kind of how it works out here. So let me go back and try to explain what we've talked about in this video, and we'll try to wrap it up. So in this video, we talked about logarithm properties. In particular, we talked about two properties. We talked about the inverse property and the product property. So with the inverse property, basically that when you have the same base as the same number inside the quantity raised to whatever exponent, the answer is the exponent itself. Because what you're asking for is, okay, my base to what power is going to give me the base raised to my exponent. And of course, that's always going to be the actual exponent. And then over here, we had an actual example here where we had log base 5. 5 squared as the quantity equals 2. And so we're asking 5 to what power is 5 squared? And so essentially you can see right here 5 to x equals 5 squared. And of course, because there's the same base here, you can essentially remove these and you have x equals 2. So 5 raised to the second power is the same as 5 raised to the second power. That's essentially what it means. And so you can see how this works out when you have the same base raised to a certain exponent. Now in this in this slide, we have here the product property, and the product property is where you have log base a to the quantity of m times n equals log base m plus log base a times the quantity of m plus log base a times the quantity of n. And so essentially what is happening here is that, again, when you have the same base, you can either have them, you can multiply them together like this, or you can separate them. Remember, these properties work both ways, and which side you use depends on the situation. So after saying that, I gave you an example. We had log base 3 times the quantity of n times 27. The first thing we did was we tried to find these numbers when they're raised to certain exponent values. And so we know that 9 is 3 squared, and we know that 27 can be 3 cubed as an example, and we had a log base 3. Now again, right here is immediately over, but we worked out everything step by step just for the sake of clarification. So when you have the same base here, you can essentially remove the base and just focus on these. So 3 squared times 3 to the third power is the same as 3 raised to the 2 plus 3. And so again, we're almost done right there. But again, we're able to remove this base also, or particularly because it's the base of the logarithm as well. So these disappear and you're left with 2 plus 3. So in other words, log base 3 with the quantity of n times 27 is essentially going to equal 5. Now, here's the thing. Another way to deal with this is as follows. You still have your base, but you put your 9 in there, and then you still have your base and you put your 27 in there, because log base 3 times the quantity of 9 is going to be 2. Log base 3 times the quantity of 27 is going to be 3, and you still get the 5. So either of these approaches here are equivalent expressions when you're trying to deal with logarithms. And remember, the primary purpose here is for being able to rearrange numbers to achieve a greater goal. And again, this will make more sense when we get into those videos. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching. Take care.